involving these fractions. We've spent all this time graphing, finding x and y intercepts and asymptotes and all the different pieces. So now we are going to solve equations and inequalities. The first piece we'll do equations today and on Tuesday, and then we'll get into the inequality piece. So with these, we're starting out with a fraction, and from what I know about you guys, you typically dislike fractions. Is that a fair assessment? Usually when I give you a fraction, everybody complains. So let's see if there is an option when we're looking at these problems to rewrite it so that we don't have to deal with the fraction. So, one thing that we have to watch on these is x can't be every possible answer. Think about our domains. What can x not equal in this problem? The denominator can't be 0. Now, does 2 ever equal 0? No, so we don't have to worry about that. Does x minus 1 ever equal 0? When? Okay, so I'm going to make myself a note out to the side that x cannot equal 1. So if I solve this and get 1 for an answer, I know it really doesn't work. Now, if I wanted to get rid of this denominator of 2, what would you do to everything? Multiply it by 2. We also need to get rid of an x minus 1, so we have to multiply by x minus 1. All right, I'm going to rewrite mine so I can be very clear about what I'm doing. You may not need to do this step. You told me we have to multiply by 2, so if I do it to 1, I have to do it to all of them. And we also have to multiply by x minus 1. So I'm taking every single fraction, every single term, I should say, times the 2 and the x minus 1. Okay, you have to do it to everything to keep it balanced. So in this first fraction, what happens? The 2's cancel. And I'm left with 2x minus 3 times the x minus 1. In the second fraction, what cancels? The x minus 1, so I'm left with 2x times 2. In the last one, does anything cancel? No, so I just have a 2x times x minus 1. Okay, so if we start multiplying this out, if I FOIL the first, then if I take 2x times 2, I get a 4x. Distribute my 2x, and we get 2x squared minus 2. So we got rid of all the fractions. Now we are just really solving a quadratic equation with a whole lot of terms in it. Where would you go from here? Combine like terms. So over here I just have my 2x squared, negative 2x, negative 3x, and positive 4. Just give me a negative 1x plus 3 equals 2x squared minus 2x. What happens if I subtract my 2x squared over? They cancel. So then I could just add over my x, divide by negative 1, and I get x equals negative 3. Okay, we have to make sure that is an okay answer. Check back at the beginning. What did we say that x could not be? So x can't be 1, so is a 3 okay? Yeah, absolutely. The nice thing about these, when you're solving an equation, you can always check your answer. How? plug -3 in for your x's up here and see if it works. So if you're ever unsure, take that time to plug it in and check the answer.
So what should we get?
It should just be the same on both sides. So for instance, if I put it in on the left, so parentheses 2 times -3 minus 3, suppose my parentheses divided by 2, gives me -4.5 plus, if I plug it in the second fraction, I get a 1.5 equals, if I plug it in over here, I get -3. So if you work that out, -3 equals -3. It should just give you a true statement when you plug it in. Other questions then? Let's do another one. What can x not equal this time? Positive 5. All right, what are we going to have to multiply by? X minus 5. And you have to do it to every single term. So there are 3 terms. You take each of them times the x minus 5. So in the first term, what happens? X minus 5 cancel, and all we have left is an x plus, second one was just a 5, so you have 5 times x minus 5. Last one, the x minus 5's drop, and we get 5. So if we remember?
Do you care if we go ahead and distribute the funds?
Not at all. So this one is just a linear equation, so you just have to get your x's by itself. And I get x equals 5. What's wrong with that? X can't equal 5. So what's my answer? No solution. So you always have to look back and check those answers and make sure it's okay. Let's do one more and then that'll probably be a good stopping place for today. What can x not be on this one? What would make 3x squared equal 0? 0. What makes 2x equal 0? 0. Can 6 ever equal 0? No. So 0 is the only thing x can't. Okay. Let's think about what we need to multiply by. What do I need to get rid of a 3x squared? 3x squared. So we have to take everything times the 3x squared. And that would cancel this. In the second fraction, has everything been canceled yet? No. It would cancel the x. If you have an x and an x squared, you could cancel out one of those. But what do I still have to multiply by there? A 2. So let's take everything times a 2 as well. so then that would cancel my 2. Has my 6 been canceled? Yeah, 2 times 3 is 6. So my 6's are canceled. So you don't necessarily have to multiply by everything that's on the bottom. I don't have to multiply by 3x squared and 2x and 6. See if anything cancels out already. So now we are left with, I have a 7 times a 2, a 9 times a 3x, and a negative 13 times an x squared. So 14 plus 27x equals negative 13x squared. What are we going to have to do here? Quadratic. Okay, so if I add over my 13x squared, can I do the shortcut? No, you have to do the full box method. So 13x squared and 14. If I multiply those, we get 182, and they have to add to 27. What would it be? Or 14. So factor. If we set each of those equal to 0, we get negative 14 over 13 and negative 1. Are both of those okay answers? Yeah, we just said that x couldn't be 0, so these answers are certainly fine. So the strategy on these is to get rid of your fraction, but you do have to check at the end and make sure that whatever answer you get won't make your denominator 0. We don't have any homework. We're not there yet. We're just going to practice some more of these.